What is up, everyone? Welcome back to the channel. Today we're going to be doing something a little bit different, not necessarily Unreal Engine related, but more has to do with C++. Now, I'm actually not in Visual Studio right now because what we're going to talk about as of right now is not fully supported in Unreal Engine, but it will be in the near future. And if you're watching this sometime later, maybe in 2018 and beyond, then this will definitely all work and apply for your work in Unreal Engine in Visual Studio. But for now, I'm actually on Godbolt. It's the compiler explorer, and it basically has a whole bunch of different C++ and other different languages. It's got different compilers, so as of right now, right here for this tutorial, I'm using Clang version 5.0.0, which I believe is the newest version of Clang. Let me go ahead and double check. Yeah. You could also use GCC 7. That will also work perfectly fine for this. The compiler flags, I'm making sure that I've got C++ 17, and we're using O3 just to make the disassembly clean over here on the right hand side. We're not going to pay attention to the disassembly, but just so that, like, if I turn this off, things are going to get a little bit busy over there, so I'm going to keep that back at O3. But today we're going to talk about the interesting and useful things that are going to be coming in to C++ 17. Now, like I said before, Visual Studio hasn't fully implemented all of these yet. I believe as of recording, there is an unstable build that is available of Visual Studio 15.5, which will have a lot of these features in it. But I wouldn't recommend going ahead and using that for your game quite yet. Maybe you get around and test with it a little bit. But let's get into the first one. All right, what we're going to start off with is nested namespaces. So nested namespaces are basically a great way for us to condense a lot of our namespaces down. So before, right, if I'm building, a different set of utilities for my function, or for different functions or different constants and stuff, I might have a namespace math, right? And I create that namespace, and that's fine. But I'm also going to want to have constants. Maybe I want to keep my constants separated from everything else. So I'm going to say namespace constants. And this is where I'm going to hold my values like pi, e, the acceleration of gravity, just different constants like that. So for here, I'm going to go with a const expr double pi and 159, right? So if I go ahead and try to use this, I'm going to say math constants pi. I'm gonna return that just so that we can see what it is, and of course it's gonna implicitly convert that over to an int, and as you can see, it's gonna return 3. All right, just like what we expected, right? So we were able to get math constants pi, but now in C++ 17 we can actually condense this down to give us to make it so that there's a little bit less typing involved, as well as shortening up our code base. So what I can do is I can break all of this down, right? And just like I would access constants down here, I can go ahead and actually set that to say math constants. So right now, constants is a namespace within the math namespace. So it's going to work exactly the same. This is just going to help us keep down the size of our code, as well as just helping with organization, right? nested namespaces, that's number one. What else we're going to talk about? We're going to talk about fold expressions. Now, fold expressions are going to help us in a number of ways, but fold expressions are really going to help us out with templates. We don't use a whole lot of templates in the tutorial series that we do. We might later on in the future, but they really add to compile times, and so I don't like to use that. And the code generated from templates usually isn't as good as the code that you can write yourself. But like for example, let's say that we wanted to create a sum functionality, right? So something like standard accumulate, where we want to add together different values that have different data types. So what we might do is we might say auto sum, and it's going to return 0, right? Then we're going to template what is that word? Parameterize this, right? So we're going to say template type name arg. I'm gonna make that capital. And then we're gonna say auto sum, and we're gonna take in sum type arg, and it's gonna be arg. And here we're gonna return arg. Now this is just really simple template stuff right here. Nothing too fancy. But the first case that we have right here is if we put in 0 parameters. The second case here is if we put in 1 parameter, and this third case here is going to showcase what it would look like if we were to put in 2 different parameters, or I'm sorry, a variadic number of parameters. So we can put in 2 parameters, 5 parameters, 8 parameters, it doesn't matter. And they can be a mixture of ints, doubles, floats, bools if you want to do that, which I would never do that. That'd be horrible and awful. But basically anything that can be implicitly converted to an int, double, or bool, or int, double, or float. So for this case right here, we're going to use a parameter pack. So template, I can't type today. And we've got type name arg, and we're also going to have another one where we're going to name this type args. Ooh. And it's going to be variadic, so we're going to use the parameter pack operator right here. And we're going to say auto sum arg and args, and we're going to return arg plus the sum of args. Oh. And if we go ahead and use this right here, I'm going to get rid of this. I'm going to sum up 3, 7.5, 23.2f, and hopefully I get, what's that? I mean, like 33? Yep, it's going to return 33 for me. So, and of course I can just keep adding stuff and adding stuff. And now we get what? 113. Right? Now, once again, this is the old way of doing this. This is the C++ 14 and under way of doing this. We can actually make this really very much simpler, and it'll take up a lot less space. So we can go ahead down here and get rid of all of that right there. We're going to get rid of this first arg. So that way we're just going to use the args right here. And get rid of this arg. Arg I'm just using to be short for argument. And as you can see right here, it's actually going to be called recursively. So it's called sum and then sum again. We actually don't need that using these fold expressions. Here, let me nested namespaces. Fold expressions. And this is only one way to use fold expressions. We can use them in a number of different ways, but the most common way is going to be with templates and variadic arguments and parameters, sorry. And I'm going to return args plus, and then we're going to use this fold expression, this parameter pack, and add that to 0. Which, if we look at it, okay, this was our first template, or our first function, right? So where we didn't take in any parameters. This is basically what that is. Let's see, can we actually get rid of that? It looks like we can. Let me go ahead and make sure that it recompiles. Yeah, so we can actually just say args plus this parameter pack, and it'll basically take everything and just add the next element into the next one. All right, so that's fold expressions. That's a really nice way, really clean way of bringing down our templates so we don't have so many, which is really great for variadic stuff. Next, what we're going to talk about is we're going to talk about if statements, right? If statements, and the same is going to be true for switch statements. So a lot of times when we have if statements, we don't always necessarily need the variable that we're checking for very long, right? So we have an int, or we're going to say we have a bool, and this is going to be, I don't know, b can double jump. We're just going to check if the character can double jump, and I'm going to set that to, I don't know, true. Why not? And we're going to say if b can double jump, then we're going to do stuff, right? We're going to let the player double jump. But if we don't necessarily need this variable all the time, we might want to limit the scope of the variable, so we can't really go ahead and be checking it nonstop for some arbitrary reason. So we might give this, its own little local scope, where we can say if bool b can double jump, and then if I try to access it out here, oh, it's going to yell at me saying, I don't know what that is. We have an use of an undeclared identifier, right? And that's what we want for this case, right? We don't want to be able to use this variable out of its scope. Basically, with C++17, what we're able to do is we're able to basically, using if statements, mimic the functionality of a for loop. Because if we look at a for loop, we can identify, or we can create a Boolean b can grapple, I guess, and say equals true. And we can initialize that variable inside of that for loop, no problem. And using C++17, we can do that with if statements and switch statements as well. So I can say if bool b can double jump equals true, and I'm going to say return 5 if it's true, which it is. So we should expect a return value of 5 from our function, right? So this is another nice clean way of being able to utilize our lines and be able to maximize our variable locality, as well as improve coherency by making our if loops look a lot more like our for loops, for example. That's number 3. That's initialization in if statements. Here, let me go ahead and I'm going to say that that's false, just so it's not returning 5 the whole time. And this is init in if statements. Also for switch. The next thing that we're going to talk about is we're going to talk about automatic type class deduction. Did I say that right? Oh well. Well, here I'm going to add, I'm going to include tuples. We've talked about tuples on this channel before in a different context, but a regular C++ tuple works very much the same as an Unreal one does. And it's called class template type deduction. There we go. So we've got class template type deduction. So what does that mean? In regular C++, or C++ 14, what we could do is we could say standard tuple of, I don't know, we've got, here, I'm going to create a struct real quick, and it's going to be vec3. And it's going to have float x, y, z. And I'm going to give it a default constructor just so that we can make this tutorial go by a little bit faster. X 0.f. And I'm going to change that to z, and I'm going to change that to y. Yay, and now our default constructor is written. We have a basic vector3 class, so an f vector, for example, right? Oh, that shouldn't be a semicolon, that should be brackets. There, we've got our nice little struct with a default constructor right there. So let's say we've got a standard tuple of a vec3 and vec3 and float, for example. I think we did that in our in the tuple tutorial. I can't remember, but we returned something with a float, right? And I'm going to call that t, and t is going to take in vec3 and 3.1f, right? You know what? No, we can actually double, and it's going to take in math constants pi. Keep everything nice and coherent. Okay, yeah, so what we have is we have our standard tuple that takes in a vec3 and a double. But what we can do, and this will work for basically anything with classes with templates, so stuff like vector, like array. In Unreal, we've got tset, and all different kinds of stuff like that, right? So all of these things we can actually treat the same when we write the code out. So I've got a standard tuple of a vec3 and a double, and I called it t. I can actually in C++ 17 get rid of these template arguments here, and the code will still run. Because what the compiler is doing is at compile time, it's actually figuring out and it's automatically deducing the types of the arguments that we pass in. So if I go ahead and we're going to compile using C++ 14, it's going to say, hey, we actually don't know what's going on. You need template arguments. So I come back here and everything's fine now because the compiler is able to automatically deduce the types of the two arguments that we passed in. And it makes it super easy to iterate on the code. So now I can come in and say, and add in 4, right? And it'll automatically deduce that t is of type vec3, double, and int. Super simple, super easy. Nice, easy way to iterate on our code. However, things can get a little crazy if you are returning like 18 values and you don't know which is which. That can get a little crazy. But the fifth and final interesting C++17 tidbit is actually going to hopefully help that. So in C++14, right, if I had a tuple t and I wanted to go ahead and get all of my values and basically break up this tuple and create individual variables for each value in the tuple. So if I wanted to say grab vec3 and it's going to get standard get 0 of t. Well, nope, that's not how I want to do that. Vec3 my location is equal to, okay, so I want to create a new vector 3. My location, I would want to get the first element of the array, or I'm sorry, the first element of the tuple t, right? And then I would do that for all of these, right? So I would go ahead and say const expr, I guess, double this pi is equal to standard get 1 of t. Let's see, does that work? Can I do that? No, it won't let me do the const expr, so we'll go ahead and double. It's not going to be const expr, but I can make it const still. Const. And I can say int this var, not this card, this var equals standard get to, I think I've made my point of t. I think I've made my point. We've got these three variables here, and this is very verbose. So standard get, enter template parameter, and then t, or the name of our tuple. So if our tuple was named that, then we'd go ahead and type all of that out every single time for each variable that we have in our tuple. Now hopefully you're probably not returning more than 3 variables from a tuple, but either way, this is a lot of typing. We can eliminate a lot of this typing by using the fifth and final tip that we've got in the video here, and that is structured bindings. Using structured bindings, we can actually make all of that fit into one line. So the way it works is you use the keyword auto, and that's the only way that you can do it. You can do const auto, you can do auto ref. So basically anything that has to do with the auto keyword that you can mix and match, right? So auto, and then I've got the square brackets here like we would use for an array, and then I can just create my variable names here. So what I had, my location, I had this pi, and I had this var. There we go. So I basically am instantiating these variables here, and then I just set this whole thing equal to t. And the code compiles. So if I go ahead and I return, instead of returning that sum, if I return this var, I should expect to get 5. And I do. And then just like any other variable or any other instance of the vec3, right, I can go my location dot y, return that, which is just going to be 0. So it's going to exclusive or EAX register with itself, or I can do something more interesting and say 13. If you haven't learned how to read assembly, I would very much recommend it. It's made me a bit better of a C++ programmer, but it's not mandatory, right? And here we're returning my location.y, and since we just used the default constructor right here, it's going to return 13. All right, and those are the five major things that we're going to take away from C++ 17. I'm pretty sure I missed some, but these are basically the five that I'm going to start using in my code, in my game code, from here on forward. And hopefully there's going to be more to come. I probably missed some. You know, these language updates are pretty expansive sometimes. And it just takes a while to go ahead and get used to writing code like this, especially like with the if statements. I'm hoping that this would be a lot easier and a lot simpler, at least in my code. But yeah, if I missed any, then let me know in the comment section down below. If you don't find that these are easier or simpler to use, go ahead and let me know as well. I'm always interested to know how other people write code because everybody has their own personal styles and everything. But that's going to be it for me today, guys. If you liked the video, hit the like button. If you disliked it, hit the dislike button and let me know why. And I'll see you next week.